So elasticity seems simple, but actually, actually quite a few things that we can do with it, and some interesting things that we can learn, and some interesting problems when it comes to elasticity. So what is elasticity? Elasticity, as defined by your textbooks, is the property of material that enables an object to return to its original shape and size after the force applied on it is removed. So to put it in simple terms, when you apply force on an object, that force changes the shape of the object. We've learned that way back in Form 2, actually. But some objects, after you remove the force, it will stay in that shape. And some objects, which we call elastic objects, or objects that are high in elasticity, are able to go back to the original shape once you remove that force. Right? So for some objects like rubber, metal, to some extent, bila kau kasih bengkok, kau kasih lepas, dia akan kembali kepada dia punya bentuk asal. So that's what we call elasticity. The ability to return to original shape after the force applied on it is removed. So elasticity follows something that we called Hooke's law. So Hooke's law states that the extension of a spring is directly proportional to the force applied on a spring, provided the elastic limit of the spring is not exceeded. In other words, okay, how much the spring extends or gets longer or gets shorter depends on how much force you put on it, right? And every spring has something called a spring constant. Think of a spring constant as a sort of ratio. How much does a spring expand per newton of force, right? So if a spring has a spring constant of say 1 newton per centimeter, then it means it takes 1 newton for the spring to get longer by 1 centimeter. 2 newtons, it will get longer by 2 centimeters. If the spring constant is, say, 2 newtons per centimeter, then it'll take 2 newtons for it to expand by 1 centimeter. That's what we call the spring constant. Now there's a catch here. Provided the elastic limit of the spring is not exceeded. So even though some objects can stretch and go back to its original position, there's a limit to how much you can stretch it. So elastic limit of materials, elastic limit is the greatest stress that can be applied to it without causing permanent deformation. So if you stretch a spring too much, you'll come to a point where it will no longer be able to go back to its original position. Therefore, it is permanently deformed ataupun bentuk dia sudah diubah secara tetap. Excuse me. So the elastic limit depends on what object. So something like rubber, you can stretch it really, really far and it can still go back without really having much deformation. And for some other things like metal, like for a spring, maybe about half the length of the original spring, and then once you go more than that, the spring will not be able to go back to its original shape. So Hooke's law, if a question asks you to state Hooke's law, then this is what you have to state lah. The extension of a spring is directly proportional to the force applied on the string. Directly proportional, meaning to say if you were to make a graph of force over extension, it will be a straight line with a positive gradient. So Hooke's law can also be written like this. F being force, equals kx, k meaning the spring constant. Now some textbooks and some websites will also write this equals negative kx. So quick K-BOT question. Kenapa ada soalan yang guna negative? Okay, dalam buku teks dia sebut sebagai K. Tapi kalau kamu Google, a lot of websites will also use negative kx. So ini soalan K-BOT. Kenapa negative? Yes, I can hear you. Go ahead. So the forces of equal Okay. Forces. You're getting there. It has something to do with the force, but think something. So, yeah, what property of the force would you need to take into consideration sampai kau perlu ada negative? It took me some time also to figure this out. I was trying to figure it out when I went ahead and Googled the formula. Okay, force has magnitude. What does force have? Direction, exactly. Remember, force equals mass times acceleration. So that means force is technically a vector quantity. So kalau kamu fikir betul spring, kebanyakan since normally Hooke's law kita guna untuk spring. If you look at most of the questions, spring dia punya arah extension is actually going down. So kalau ikut betul, the extension will write as a negative number. Usually. But depends lah if you want to take into consideration the direction or not. So, but for us, we'll follow the textbook. So this is the formula that we'll use most of the time lah. F equals kx. Right? Yeah. It also took me some time to figure out kenapa semua formula di website lain negative kx tapi buku teks kx. Takkan itu buku teks yang salah. Then I realized it's taking into consideration the direction. But for our purposes, we'll not consider direction. We'll just consider F equals kx. So if we were to make a graph using Hooke's law, where normally our horizontal axis is x, our x-axis is x standing for extension, and our vertical or y-axis is F or force, then the spring constant would be, if we were to calculate the spring constant just by rearranging the formula, K would equal F over X, force divided by the total extension. And if we calculate the gradient of a graph, we know how to calculate gradient. We would use the same formula actually, because we would calculate the force divided by the extension. So gradient of a graph, if you have a graph, will be equal to the spring constant. So yeah, we'll do some examples later. Now, elastic potential energy. So that's another thing. So elastic potential energy is the amount of work done to stretch the spring. Right? So kalau kamu stretch satu spring sebanyak 10 cm, berapa banyak kerja yang kamu sudah lakukan? Work done. How many joules have you done to stretch that spring? Okay, so work kita tahu defined as force kali dengan distance. We learned that in Form 4. So basically, we do the same thing with a spring, which is we calculate average force kali dengan extension of the spring. Right? It's just the same thing. Now, there are several formulas given in your textbook. Okay, one possibility is 0 plus F. Now, why 0? We are finding the average force. So 0 is the lowest force when there's no extension, and F is the highest force in the graph. Right? Divided by 2 times X. X being extension, so 1 over 2 Fx. That's one way for us to calculate the elastic potential energy. And actually, if we were to base on a graph of F against X, area under the graph equals area of the right angle triangle. So there's a right angle triangle form. Let me just give an example first. Here we go. So if we were to graph something like this, this would be the force, this would be the amount of extension, which will be in centimeters. Okay, a spring constant, because of Hooke's law, the graph will always be straight because it is directly proportional. Now, if you see a graph where the line is not straight, then something is wrong with the spring. So either the spring does not follow Hooke's law, or sometimes you might see a graph that looks like this. I've seen questions that look like this. They have a straight line, and all of a sudden in the end, the line curves off like this. If the line curves off like this, that means here is your elastic limit, where the spring is no longer able to come back to its original shape. Alright. But the way we'd calculate the area is simply by calculating the right angle triangle. So, area on the graph, I'll just write area on the graph equals, obviously we can just use the formula for a triangle. So x and f, 1 over 2 times f times x. So you still go back to the same formula, which is 1 over 2 fx. You can use that formula. Now, if you are in a situation where you do not know how much force is being used, kadang-kadang ada soalan di mana dia tidak bagi tahu pun itu force, then what we can do is we can use this formula instead, di mana kita substitute saja force dengan kx, because we just learned just now that the total force that is being outputted equals kx, spring constant, over the x. So if you do not have the force but you have the spring constant and the extension, you can just substitute the f here with kx, and you end up with this formula, 1 over 2 kx square. So any of these actually two formulas, because the first two are almost the same. So either this formula, so formula ini kamu guna kalau kamu tahu force dengan extension. Kalau kamu tidak tahu force tapi kamu tahu dia punya spring constant, then kamu boleh pakai formula ini. Either one will get you the same answer. So let's do an example here. So analysis of the graph of force against the extension of spring. So from the graph F against X for spring R, determine value of spring constant by calculating the gradient of the graph. Let's read all the questions first. And then determine the elastic potential energy when spring is stretched by 0.2 meters by calculating the area under the graph. Alright, so let's try question A. So question A is to calculate the spring constant. So spring constant is well, we know that force equals spring constant times extension. So we just rewrite the formula as spring constant K equals force divided by X. Right? And so we can also use the same thing, calculate the gradient of the graph. So we can just take any point in this graph. So I'm going to take the furthest point, the biggest point, the last point. So the last point is we have a force of 8. And we have a extension of 0.2. So if we do the maths, we would just calculate. So we get a final answer of 40. Wait, no, that can't be right. Oh yeah, that's right. 40. So 40 newtons per meter. In other words, it would take 40 newtons to extend the spring by 1 meter. Alright, let's go ahead to question B. So question B is to determine the elastic potential energy when the spring is stretched to an extension x equals 0.2 by calculating the area on the graph. So we'll go ahead with question B. So since it's asking us to calculate area on the graph, we'll just use the formula for that. So area on the graph equals, since it's a right angle triangle, 1 over 2 times F times X. 1 over 2 times F here is 8. And X here is 0.2. And so if we will calculate that, we'll get a total answer of 0.8. 0.8 newtons. So I hope everyone is following me so far. Now, what if the question did not give you the force? Let's say dia tidak suruh kamu do it by calculating the area under the graph, ataupun dia tidak pun beri graph tapi kamu hanya tahu dia punya spring constant. Then we can use the formula that we learned earlier. So let's take that as a bonus question. Let's say spring constant, dia punya force tidak kena bagi, tapi dia kena beri dia punya spring constant saja. So the first two questions actually you can find it in your textbook, but this one is not in your textbook. I just added this one. So let's say tiada dia punya force diberi, cuma spring constant. Kita tahu sudah spring constant equals 40. Itu baru kita cari tadi. So what can we do? So let's go back and check the formula. So what we can do is elastic potential equals 1 over 2 kx square. So this time we only use the spring constant and the extension for us to calculate the elastic potential energy. And so we'll use the same value. So 1 over 2 K is 40. X is 0.8 square. And so if we were to put that in our calculator, we should get the same answer. So 20 times 0.8 times 0.8. Let me just check my answers first, yeah? Oh, sorry. Why did I put 0.8? It should be 0.2. That's why I got wrong. 0.2 because we're talking about extension. Extension is 0.2. Yes, and you still get the same final answer of 0.8 newtons. So either method will get you the same answer. It's just that it will depend on apa maklumat yang diberikan dalam soalan lah. Kalau soalan dia bagi force dengan extension, you can go ahead and use this formula. If not, kalau dia hanya bagi spring constant dan dengan extension saja, then you can use this formula. So it just depends on which question and the information. Alright, let's continue. So the spring constant are affected by different values. I'm not going to go into this too into detail for now, but just be aware that these four things will affect the spring constant: the material of the spring, the length of the spring, the diameter of the spring wire, and the the diameter of the spring itself. Maksudnya berapa besar dia punya gulungan spring, and the thickness of the spring wire. Okay, so if you look at the factors, for material of the spring, ini sedia maklum lah, bahan yang berbeza akan memberi spring constant yang berbeza. And then length of spring, okay, spring yang lebih pendek akan ada spring constant yang lebih tinggi. Spring yang lebih panjang ada spring constant yang lebih rendah. Okay, diameter of the spring, so smaller diameter causes higher spring constant, larger diameter causes smaller spring constant, and thickness of spring wire, okay, larger diameter means lower spring constant, larger diameter means higher spring constant. Alright, so solving problems involving force and extension of a spring. So just now what we did was mostly questions involving graphs. Now we'll take a look at the spring itself. Okay, so when we have a system of springs, so a system of spring means you take several springs and combine them together to make one system. So if we take springs in series, meaning to say line them up like that, the total extension of spring 1 and spring 2, the total expansion, you'll have to add up spring 1 and spring 2 lah. Okay? In other words, bila kamu calculate, kamu kena calculate extension untuk setiap spring satu-satu. So let's say this spring here has a spring constant of 2 and a force is applied of 2 newtons. Okay? Kamu kena calculate berapa spring yang pertama extend, and then separately you have to calculate how much the second spring extends. Tension is the same on both strings. Kalau 2 newton dia punya force, dua-dua spring akan mengalami 2 newton. Okay, because just imagine lah, ada pemberat di sini bawah. The first spring dia kena angkat dua itu pemberat. Yang spring yang ini pun dia kena angkat itu pemberat juga. And actually kita ignore sebenarnya berat itu spring. So we're assuming that the spring itself has no weight lah. Now kalau springs in parallel, di mana springs disambung yang begini, then tension, daya itu kita bahagi 2 ataupun berapa sajalah spring. So for example, kalau berat di sini ialah 10 newton, setiap spring masing-masing akan mengangkat 5 newton. Kalau 2, kalau 3 kamu bahagi 3. Kalau 4 kamu bahagi 4. Okay, and the extension, sebab tension ataupun jumlah daya yang dialami oleh setiap spring sudah dikurangkan ataupun dibahagi 2, dia punya extension ataupun the extension pun kamu kena bahagi dengan 2. Or kalau 3 spring bahagi dengan 3, and so on and so forth. And so there are some interesting questions lah that we can solve. So in your textbooks, let's go ahead and solve these questions. Question number 1. A spring with original length 50 millimeters extends by 6 millimeter when stretched by a force of 12 newtons. Calculate the spring constant of the spring. So let's take a look at the information that we have here. So what I like to do, I've said this before, I like to write down all the information first. So first we have to write down all the information. So original length is 55 millimeters. So we write it down. Okay. Extension or X is 6 millimeters. And the force is 12 newtons. Once we have all our information here, okay, we look at what we need to look for. So what we need to look for is the spring constant, or K. And then we think, what formula can we use? Okay, K equals F divided by X. So we take the information and just put it in our formula, just substitute. So 12 newtons and 6 millimeters. And so we know that our final answer will be 2 newtons per millimeter. Right? Meaning to say it takes 2 newtons to extend the spring by 2 millimeters. And that would be your final answer. Okay? Now if you choose to, you can convert it to meter if you want to. But for now, we don't have to yet. We don't have to convert it into meter yet. But for the next questions, for some of the questions, you might have to change it to meter. Alright, let's go on with the second question. Alright, so now this is quite long. So let's see how much. We still have plenty of time, so we'll go through each of the questions one by one. So you have three arrangement of springs or three spring systems. We have a pair of springs in series, and then in arrangement B we have a pair of springs that are, should I say, in parallel. And then in arrangement C we have a combination of parallel and series. So each of these spring systems kita kena calculate dengan cara yang berbeza. So figure 1.4 shows three arrangements of springs consisting of springs identical to the one mentioned in A. So asal ada soalan yang berdasarkan soalan yang sebelumnya, please be careful. First of all, make sure yang jawapan kamu di A itu betul. Ya. Because kalau jawapan kamu di A salah, then B pun salah lah automatic. Now for each arrangement, determine the tension of each spring, the extension of each spring, the total extension of the system of springs, and the total length of the arrangement of the springs. Okay? So, number one is tension ataupun jumlah daya yang dialami oleh setiap spring. And then number two is extension of each spring. Maksudnya, berapa banyak pemanjangan setiap spring. So, each spring individually. Number three is total extension of the system. So, sistem secara keseluruhan berapa banyak dia memanjang, and total length ialah panjang keseluruhan lah selepas dia sudah dipanjangkan. So let's take a look at our problems here. So every spring system dia melalui ataupun it has a load of 12 newtons. So let's start one by one because this is going to be quite, well, not quite long, but we have to do it one by one. So for question number one, let's say arrangement A. Okay, so we know that the springs are equal. It has the same spring constant and the same everything, same length. So first question, tension in each spring. Okay, I've already mentioned this. Kalau spring disusun dalam bentuk series seperti ini, each spring will carry the same tension. Kamu tidak perlu lagi bahagi. Sebab dua spring kena angkat 12 Newton. So, for number one, that's easy. Just say 12 Newtons. So, P, 12 Newtons, and Q also 12 Newtons. Both springs are experiencing a tension of 12 Newtons. Number two, the extension of each spring. Okay, now because both springs have the same amount of tension, the extension is also the same. So, how can we find the extension? We use the same formula. Force equals kx, right? And so x, since we're looking for extension, x will equal force divided by k. And we know that the force is 12 newtons, and we know that the spring constant is 2. And so the total extension will be 6 millimeters. So both P and Q, so extension of both P and Q are the same. Both have an extension of 6 millimeters. So total extension, you just have to add the extension from both springs. So add the extension of both springs. Spring A would be, so total extension will be 6 plus 6. So you have a total extension of 12 millimeters. And now finally, total length of the arrangement. So kamu kena tambah dia punya original length lah. So kita tahu original length tadi ialah 50. So original length is 50. So kamu kena, so 2 spring. So 50 plus 50. Tambah dia punya extension. So 12. So you have 112 millimeters. Okay, setakat ini jelas? Am I going too fast? Or is everything clear to you so far? Tentang cara kita mengira extension dan sebagainya with springs. Okay, so setakat ini belum ada soalan kali. Okay, it's okay. Later we can come back to it if you have a question. Alright, so that would be question number 1. Now, question number 2. And actually, the answers are all in your textbooks, but the textbook did not show how it calculated one by one. So that's what I wanted to show you. So let's go with the second system. So second system, arrangement B. We have the tension of each spring, and same thing, we have to calculate the same thing, but this time the two springs are arranged in parallel. So this time we have to calculate a little bit more. So in arrangement B, we have spring R and we have spring S. So the tension of each spring, this time, dia bukan lagi sama, tapi because the two springs share one load, kita kena bahagi dengan 2. So tension in R and S, we just take tension equals to, 12. So we have a total of 12 newtons and we have two springs. So kita kena bahagi 2. So we have a total of 6 newtons. So R dengan S masing-masing mempunyai 6 newton. 6 newton of tension. So R equals 6 newtons and S also equals 6 newtons. Alright, so number 2, extension of each spring. Now we can just calculate the extension of one spring. So X equals extension is force divided by the spring constant. So spring constant is 2, force is 6, so we have 3 millimeters. So each spring is extending by 3 millimeters. So let me write it nicely here. So extension of R equals 3 millimeters. Extension of S equals 3 millimeters. Now remember, when you're writing down your answers, make sure kamu tulis jawapan kamu sampai hujung. If you just write 3 millimeters, it doesn't have any meaning unless you say that the 3 millimeters is the value of R and S. Otherwise, you may or may not lose points depending on who is checking your answers. Okay, so that is total extension of each spring. So each spring will extend by 3 millimeters. Question number 3, total expansion of the system. Okay, now because the two springs are in parallel, they'll extend together. So we know that will only expand. Okay, total extension is still 3 millimeters. Because it's side by side. Now the total length, we have the original length, which is 50, plus the extension, which is 3. And so we get 53 millimeters. So that is your total length. All right, so far so good, clear. So that is when we have series or parallel. Now it gets more interesting when we have a system like this one, where you have a combination of parallel. We have a combination of parallel and series. So in that case, we have to calculate each section separately. Alright, so arrangement C. So let's start with number 1, tension on each spring. So if we look at the first spring, W and U are basically connected to each other in series. Meaning to say W and, well, TUV. TUV kita boleh anggap ini sebagai satu unit. So we'll consider this one unit and W will be the second unit. So W, since it's connected in series, W you do not have to divide the force. So W, automatic kita boleh nyatakan the force on W is 12 newtons. Alright, now for T, U, and V, these three are in parallel. So each of these share the force of 12 newtons. So kita kena bahagi dengan 3. So tension in T, U, and V equals 12 divided by 3, meaning to say 4 newton. So each of these springs, T, U dengan V, masing-masing dia mengalami tension ataupun force sebanyak 4 newton. Okay, it's, well, that one so far is quite simple lah. So just make sure kamu kena separate lah, kamu kena tahu lah which formula ataupun mana satu kamu kena anggap sebagai series, mana satu kamu kena anggap dia sebagai parallel. Okay, so that's question number 1. Question number 2 is the extension of each spring. Kamu kena kira satu-satu lah. So we'll start with W. Extension of W is, well, we'll use the spring. We'll use the same formula. So extension of W equals X equals F K. And so force is 12, spring constant is 2, therefore 6 millimeters. So extension of W is 6 millimeters. Just like one of our earlier questions. And then for T, U, and V, okay, we use the same formula, but this time we use the value of 4 newtons. And so what we can do, well, there are several ways we can do that, but the easiest way is to use the value of the force lah on each spring. So extension of T, U, and V. You could write extension T equals extension U equals extension V, right? And so the extension would equal, again, same thing, but this time only 4 newtons divided by 2. So you only get a total of 2 millimeters of extension each. So extension of T equals 2 millimeters, extension of U equals 2 millimeters, and extension of V equals 2 millimeters. So if I had more space, I would write that all out, but I'm running out of space on my whiteboard. Now the total length of the arrangement of the springs, which is the total extension. Let's do total extension first. So total extension, okay, the first section will extend by 2 millimeters. The second section will extend by 6 millimeters. So you get a total of 8 millimeters of extension. And the last question, total length of the arrangement, 50 plus 50 plus 3, plus 2 plus 6 equals 108 millimeters. Alright, and I know that's the correct answer because I checked the textbook and your textbook also shows the correct answer. So, it's not that hard, it's just a matter of kamu kena berhati-hati lah when you calculate each and every one of the springs. Okay, so far, are there any questions with this one? Setakat ini jelas? Jelas? Okay, so far. Anyway, you can review this after class anyway. Okay, if that's the case, then that's everything already for chapter 1. I don't have any slides left. Um so what I want you to do, we still have how many minutes? We have about time is 8:22, so we actually have around 45 minutes or so. So what I want you to do is, well, actually, let me just stop this recording first.